Hi, I'm Shubhanker from Hewlett Packard Enterprise, and DCcluster-Opt introduces a high-fidelity benchmark for sustainable AI workload scheduling across geo-distributed data centers. It bridges the gap between the research and real-world operations using multi-agent reinforcement learning and agentic LLMs. The exponential rise of foundation model and LLM compute has made AI's energy use and carbon footprint unsustainable. Large scale HPC systems now demand intelligent, carbon aware workload management across global infrastructures. Managing global AI workloads is a multi objective optimization challenge involving trade offs among cost, carbon, latency, and water usage. However, progress is limited by the absence of realistic physics informed benchmarks that unify scheduling and cooling. DCcluster-Opt is a novel open source benchmark integrating real AI workloads, environmental data, and data center physics for multi objective optimization. It enables fair, reproducible evaluation of sustainability aware scheduling algorithms across global clusters. Each 15-minute time step models a Markov decision process where an AI agent decides where and when to run tasks. The reward balances competing goals like energy cost, carbon emissions, SLA compliance, and water usage. A hierarchical control system combines global RL schedulers at the cluster level with local RL cooling agents at the data center level for coordinated energy optimization. The RL policy distillation into LLMs makes the system auditable, explainable, and adaptive to real world deployment. It involves a textualization engine which fine tunes the LLM with the static action pair derived from a trained RL agent. The agentic framework mirrors human operators like sensing, analyzing, validating, and acting within a closed loop simulation. LLM based agents translate complex states into interpretable reasoning, ensuring safety and transparency in decision making. This shows the overall flow of our work in creating the agentic mesh from the model through RL and distillation into LLM reasoning, leading to a robust benchmark. The benchmark fuses diverse data sets like the Alibaba workloads, electricity prices, carbon intensity, weather, and network latencies. These real world signals ensure controllers learn to follow renewables and avoid high cost, high carbon conditions. Joint optimization of global scheduling and local cooling yields over 11% energy and CO2 savings versus static baselines. The framework reveals how AI controllers can dynamically balance sustainability with cost and performance. Distilling RL policies into LLMs enable reasoning-based control that generalizes and scales to new data center clusters with different scales without retraining, while adapting to dynamic priority changes on the fly. These controllers produce human-readable justifications for each scheduling decision, fostering trust and operational adoption. LLM control matches and exceeds the RL performance, as you can see in that bar graph. Now, DCcluster-Opt provides a blueprint to cut real operational costs and carbon emissions through holistic AI control. By integrating sustainability, resource efficiency, and risk mitigation, it helps enterprises and national labs achieve measurable ESG impact before deployment. Future scientific infrastructures like the American Science Cloud demand autonomous, trustworthy AI control planes. Our framework lays the foundation for resilient, self optimizing systems that continuously balance cost, carbon emissions, and scientific throughput. We are releasing DC Cluster Opt as an open source ecosystem to enable reproducible and collaborative research. With its Gymnasium API, ArrayRL integration, and documented datasets, it empowers the community to advance sustainable AI for next generation HPC systems. Thank you.